Welcome back to Lesson 1 Tutoring. Today we'll be going over the law of sines. Before we get into this video, let's start off with what the law of sines is and why it's used. Traditionally, when we think of solving for the side of a triangle or an angle, we think of using the Pythagorean theorem or trigonometry. The problem with these methods is that they can only be used in a right triangle, and as many of you might have already found out, as you progress through math courses, you'll see more and more triangles without a right angle. To overcome this obstacle, we use the law of sines, which is a different method that gives us the same information but in an oblique triangle, or a triangle without a right angle. The law of sines states that in a triangle ABC, side A over sine angle A is equal to side B over sine angle B, which is also equal to side C over sine angle C. It's important to note that the sides directly opposite to the angles are corresponding, as shown by the diagram here. Using the law of sines, you can find all the missing values when given an angle, and a side, or when given an angle, the corresponding side, and another angle. In this problem, we are told that the measure of angle A is 118 degrees, the measure of angle B is 22 degrees, and side C is 24. In order to use the law of sines, we need one corresponding side and angle pair. In this situation, since we're given side C as 24, we can actually solve for angle C directly. In order to get it, we have to use the sum of interior angles in a triangle, which is 180 degrees, and subtract that from the measure of angle A plus the measure of angle B. And then we eventually find that angle C is 40 degrees. Once we do all of that, we can plug those values straight into the law of sines and set it equal to a corresponding pair of A, since that's the second largest side. We end up getting 24 over sine 40 is equal to A over sine 118. From here, we can cross multiply and simplify using a calculator. On these types of problems, I like to round to the nearest hundredth, but it's really preference. And also, we want to make sure our calculator is on the degrees mode for these types of problems. Now that we have the value of side A, 32.97, and the measure of angle C, 40 degrees, the only thing left to solve for is side B. Since we have two completed corresponding pairs, we can plug either of them into the law of sines, and then we simplify through cross multiplication and division. By doing this, we find that the value of side B is 13.99. At the end here, I just went back and circled that measure of angle C is 40 degrees, and with that, we're done with the problem. In this next problem, we are given a corresponding angle A, which is 35 degrees, and side A, which is 18, and then another angle B, which is 55 degrees. Since we already have a side angle pair, we can go straight to putting in the values into the law of sines. First, we'll set up the equation to solve for B, and we also have to keep in mind that we're going to round to the nearest hundredth in this. After finding B, the next missing value that we want to find is angle C. Since we're given two angle measures already, we can actually just add them up together and subtract them from 180, just like we did in the previous problem. By chance, we find that C is actually 90 degrees, which makes this whole thing a right triangle. From here, we could either use trig or the Pythagorean theorem to find side length C, but for the sake of this video, we'll continue to use the law of sines again. Just like previously, we will plug the values straight into the law of sines, but this time we are simplifying for side C. After finding the value of C, we have now found all the missing values and completed the problem. Tune in next week for a tutorial on the ambiguous case for the law of sines.